Okay, let's talk about standards, specifically those that affect the UK watermist industry. Let's talk first about the role of standards, and for this I have cited clause 9.4 of BS0, which is considered the standards of standards and is a free document to be downloaded from BSI. So clause 9.4 says that between the many types of standards, there is a specification standard which gives an objectively verifiable absolute requirement and which is suited to give performance criteria for certain products. On the other hand, there is a code of practice, and that is one which has recommendations and supporting guidance that reflects current good practice. So within the 8458, I'll give you an example of each present in that document, even though it's called a code of practice. A specification example we have, which is a performance requirement, is the table from the testing in Annex C, which shows what are the maximum temperature criteria that are allowed in the fire test to demonstrate that the system performs as a good suppression system. On the other hand, as a code of practice, we have an example of a historical practice, which is the system actuation should be automatic by glass bulb or fusible link initiated by heat generated from the fire. So the difference between the two is very simple. The performance requirement has a clear and verifiable objective requirement. An analogy here in this cartoon is where the requirement is getting from A to B without falling in the precipice safely. So it could be achieved in a number of ways, but there is a performance criteria that can validate whether it has been achieved or not, which is, did you get to the other side safely? A code of practice, on the other hand, just defines in what way we've been doing this historically. So an example here is a way to get from A to B has historically been the use of a ladder. It's not precluding other ways, it's just documenting what is the common practice that you can get from A to B. So basically this just shows that standards do not typically look forward, they look backward because they are reflecting what are mature practices, what is common, and not necessarily will, especially in the suppression world, look into how could innovation and technological advances change the current practices and whether the performance requirements can be tested with these new systems despite them being in a code of practice document. And the other thing is that they are a continuous work in progress. So they get reviewed from time to time, in part to fix mistakes or potential misinterpretations, but also to ensure that they are adopting the progressive change in good practice in the industry. And that might be through new technology or just a good practices to improve reliability and robustness of systems. So let's have a look at in more detail into 8458. Well, just looking into the scope of it in clause number 1, we can already learn a lot of what is its objective. Firstly, it is a code of practice. It is stating that these are recommendations, so they're voluntary recommendations, they're guidance, they're not the law. You're not obliged to follow them. However, if you choose to follow them, you should declare how you're following them and how you're not following them if you are deviating in any of the clauses. So it's a voluntary document, but the declaration of compliance to it brings with it the requirement to demonstrate that compliance. Secondly, it's talking within its code of practice of within that document about the design, the installation, the water supplies, the commissioning, and the maintenance of the system. These are all good practices in how do you get a system to perform as intended. But additionally, there is a testing part. This is Annex C, which is the performance content of this document. And finally, it is talking only about automatic nozzles. There are many other nozzle types for watermist, but this has a limited scope that is addressing only automatic nozzles. And by that, it means the mechanical automatic. We'll get into that a bit later. However, if we go back to BS0, the standard of standards, it does say that to avoid anti-competitive effect and to avoid impeding innovation, provisions should be expressed in terms of performance rather than design or descriptive characteristics. If we looked into clause 5 of 8458, we can see that it says that the system actuation should be automatic by glass bulb or fusible link initiated by the heat generated by the fire. So you can clearly see that these contradict themselves slightly in that it would have been a better way to describe clause 5 by not specifying a glass bulb or fusible link, because even though this is a best practice, it is a descriptive and design method. Instead, a better way would have been that the system actuation should be automatic, initiated by the heat generated by the fire. It's still capturing the best practice in terms of it should not be manual, it should not be activated by smoke, for example, but it's gone a bit too far in terms of being descriptive in how you should achieve that. So very code of practice type, not very performance in that sense. So if we make a simple comparison here of what are the differences between how the traditional watermist systems are described within the scope of 8458 versus how watermist is, we can see that the activation is mechanical versus an electronic trigger. You can see that the system design is a wet pipe versus a non-pressurized dry pipe system. You can see the nozzle location is ceiling mounted versus a wall mounted, but the fire test is the same for both systems. They're both using Annex C as a measure of performance, because that is in fact the performance content of that document. Unfortunately, typically the industry interprets this as a non-compliant system, but that is an incorrect interpretation because it never intended to be compliant with the code of practice requirements in the first place. It only intended to demonstrate its fire performance. So it is a different approach, and as a result, the code of practice items should be separated from the performance items of that document. And the result of that would be that the first part means that Ultimist is out of scope of these requirements because they are common practice. It doesn't mean that that's the only way of doing it. And Ultimist has chosen to approach it from a different perspective, have a different approach. However, the fire test remains relevant, and Annex C is the important part of the document that needs to be scrutinized for the system to ensure that it will perform, that there's a verifiable item to demonstrate that it is fit for purpose. So when I talk about the fire test, I'm talking Annex C, I'm talking about this type of setup. It is a stylized furniture test. This just happens to be a sprinkler test where the sprinkler is on the right and the free burns on the left. And it's a useful video because it shows the purpose of activation, the purpose of suppression, where it is limiting the size of the fire, not letting it progress into dangerous levels, as you can see on the left. So this is what a verifiable, with temperature limits to verify their performance, this is what a performance requirement of a system is and which should be verified. This means that we're observing whether the system is being able to get from A to B regardless of the approach that's being used. Instead of using a stencil to verify that it's a ladder, it's in fact verifying that it gets from A to B even if it is a lift instead of a ladder. It's an alternative means to achieve the same performance outcome. So now I'll just go into a bit more detail of the difference between compliance and certification, because this it's a source of too much confusion in the industry, which might impact the quality of systems in the field. So just to make things simple, when there's a statement of declaration of compliance, this is a first person declaration. It could be an installer, a manufacturer, and it's basically saying, trust me, I am declaring that I comply to this. It is voluntary, but it's also first party. So there's a natural inherent conflict of interest here, which should be verified and audited to ensure that that declaration is correct. So this can be improved by carrying out third-party testing. This is where the test is carried out by someone else than the person declaring their compliance, but basically it's just saying that it wasn't them that tested it. They handed it over to a third party to do that test. It could be an accredited UCAS lab. It can be just a lab that maintains a quality system, which is what BS8458 does. But it is a level of improved demonstration of data of how their system performs, and it's basically that first person still stating, trust me, I haven't done this test in my backyard, it's been a third party test that has done this, but it's still declared by that first person. A much better level than that is where there is a third party verification. So now the declaration is not coming from the first person, it's not coming from the manufacturer installer. This is coming from a third party where they, as the scrutinizer, are saying that you can trust the evidence that's being provided for that first person. So this is basically an audited performance data or declaration of compliance, and is certainly much better than the first two. The ultimate level is the certification level. This is where the third party is fully involved as the scrutinizer, and in fact can go beyond what is common practice of scrutinizing systems or services, and they're the ultimate endorsing capability of saying, I have tested this to exhaustion, and I can tell you that you can trust this declaration, or I am in fact declaring that you can trust the system or you can trust this installation. And to this end, this is exactly what we do with watermist for BS8458. We do not declare compliance to the standard because obviously we're out of scope of it due to our different electronic approach to it. But we do test to the Annex C of 8458, and we do have third-party testing evidence of that. But way beyond that, we go through a BSI verification certificate, which scrutinizes and audits not only the fire test data, but the product DIOM and the product documentation in terms of control of components and the quality system involved. So this is an audited a performance declaration by BSI that demonstrates that the system performs to that Annex C, which is the performance clause of BS8458, despite not being a frangible bulb, but still activating automatically and through the heat initiated by the fire. So again, certification is where this third-party scrutinizer can go into way more detail and even develop new tests to ensure that a system will perform as intended, will go from A to B, and these custom tests can be defined then to ensure that that certifier, that scrutinizer, has the confidence to say that that system performs. Now, going a bit more detail into watermist systems and how does compliance and certification vary. There's different levels, both in terms of whether it's component or system, whether a declaration of compliance is given, or component and system, whether it's being third parties certified. Let's have a look into these. First, a manufacturer can declare compliance to a standard These are two examples of standards that have been published, although BS8663 is one that's been published for a very short time, and as a result, there are no components that have yet, no nozzles that have yet been published with this declaration done by a third party. This is typically done by a third party lab. At the same time, a manufacturer can get a component certified, which is significantly better, where one of the accredited laboratories will do a thorough test schedule on that component and then provide a certification. So the documentation, the certificate that's being produced is that of a certification, is not of compliance, or is not of third-party verification. And this is going to be done by one of the accredited labs that typically work with watermist, like the BRE, UL, VDS, or Factory Mutual, FM. Similarly, on a system level, a manufacturer can declare compliance. This can be to a standard like 8458 in the UK, EN 4972 Part 1, which is coming into the UK now, or for example NFPA 750, which is the American watermist standard. A improved level beyond that, of course, is that of certification, where an accredited lab will do the certification process for the whole system. This means not only components, but ensuring that the system will work as a whole together and perform in a fire test, whatever the fire test that the certifier has decided to run, beyond what typically would be present in one of the standards like 8458 or NFPA 750 or EN 14972. Finally, the same thing can be done on installer level, where an installer declares compliance, but in that case, the installer is declaring compliance not only to a standard like 8458, but also declaring compliance to the manufacturer's DIOM. This is the Design, Installation, Operation, and Maintenance Manual, which the manufacturer produces to explain how that specific watermist system should be installed, designed, and maintained. It's important that in the watermist world, the DIOM comes hand in hand with a standard, as opposed to what typically happens with sprinklers, where there's no real DIOM, there's just the installation standard like BS9251, which captures the best practices in how to install sprinkler systems, who tend to be all the same, so there's no need for a DIOM in that sense. And finally, we can have installer certification, where there is a scheme like BAFE or FIRUS, where the installer gets scrutinized to ensure that they have the competence to install the systems that they've been certified to do. And finally, what happens when if a system is out of scope? Well, a custom certification has to be developed, and this is exactly the process that we have been carrying out proactively over the last 5 years, with well over £1 million investment into it. And it's a process that takes a long time because new tests need to be developed for a new system, and as a result is not reasonable as an expectation to expect that an innovative system has a certification as soon as it is in the market. However, it is a reasonable expectation to have an established system for which there is an established standard for it to be third-party certified if there are these certification schemes. So there are certification schemes for traditional watermist and sprinkler systems throughout the world, and there are many Scandinavian, German, and American systems that have been certified, but currently there are no UK systems that have been certified by a UK UCAS accredited laboratory that is different from third-party testing. So there are no systems that have yet been third-party certified in the UK just yet. However, in the US, in NFPA 750, which has a mandatory renewal and update every 3 years, Their 2023 edition has recently been published, and in that document, the use of electronically operated automatic watermist nozzles, which is exactly what Ultimist is, has already been published. So in the US, the use of electronically controlled nozzles is already considered a current good practice. And that's because their process of updates is consistent at 3 years intervals. And unfortunately, BS8458, last published in 2015, has been taking much longer to get updated, and as a result, hasn't been able to adopt the more recent best practices, as well as clarify potential misinterpretations. This is well overdue, which we hope to conclude as soon as possible. So in the end, which system is truly compliant and who will scrutinize it? So I'll give you a couple of examples of what we've seen in the market where systems declare compliance, but in fact they wouldn't perform. So effectively they're not compliant despite declaring compliance to a standard. And whose role is it to scrutinize it? It is the approver, it is the buyer, and who need the support from technical expertise when that availability is not there in-house. And that's where third-party verification or certification are helpful, because they verify third-party competence. So these first of these two examples are the adequateness of the water supply. So it's a very simple requirement that states that because you cannot control how many nozzles are going to activate when you have a fire, but the maximum number of nozzles in that room, up to 4 nozzles, can be expected to operate, the water supply has to be able to provide the water to up to these 4 nozzles activating in the property at the same time, and the sum of the flow of those 4 nozzles is what the pump and the water supply and the tank all have to be able to provide. So this is a very simple and verifiable requirement, which frequently gets forgotten when the system is installed, because this is an installation specific requirement. It's not something that a manufacturer can comply to. It's an installer has to verify that. And obviously the consequence of when an adequate water supply has not been designed and ensured in a property, what will happen is that there will be a smaller water flow than that has been validated in the fire test, and that will result in a larger fire than what has been validated in that fire test, where that flow and pressure were available in that 1 or 2 nozzles that activated in the test. Another very simple verification, very easily in installations, is verifying that the temperature of the bulbs on the nozzles that have been installed are the same that have been tested. So every bulb color in a mechanical water mist or sprinkler nozzle is a temperature rating for that nozzle to activate. And of course, the more sensitive, the better it will perform in a fire test, and the less sensitive, the worse it's going to perform in the fire test. So it is key that when the declaration of compliance is being given by the installer on the system that they're using, that the temperature of the bulb that's been installed is one for which there is a report of a fire test that demonstrates that they perform. And this is something we see frequently not happening. So these are two very simple performance requirements that can be observed in the field through simply looking at documentation and observation of an installed system in the field. So just as a summary, what is the way forward? Well, a buyer, a verifier, is responsible to verify whether a system is fit for purpose. Most importantly, this can be done through verifying its compliance, not only accepting a first-party declaration of compliance, but auditing it and scrutinizing it, and verifying that it performs to the relevant tests, and that those relevant tests will be replicated in an installation in the field in the form of correct bulbs, in the form of an adequate water supply. And then there's a improved level of verification, which is through third-party verification, where a third party has been involved in auditing the information provided by that first party. And finally, there is the ideal third-party certification of both components and system, which demonstrate that the whole componentry and system do perform as intended. And yes, it is the buyer's and approver's responsibility for this task. This is how it works in the UK. And this is just a presentation that tries to clarify some of the common confusion and demonstrate a path so that this verification can be done by approvers. So thank you very much for your time.